Hey guys, this is a video on the ideal gas law. Okay, so what is the ideal gas law? Uh, don't go rid of that one. Okay, so the ideal gas law is basically states that a pressure times a volume equals some amount times R times a temperature. Okay, so what does that mean? Well, R is a constant and it equals this value here. You will see this the same R with a different value, and that's 3.14 and then something, 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 something. You don't use this value for R because it corresponds to different units, and you really want these units when you're doing the ideal gas law. Okay, so um, besides that constant, we have four variables in here. We have temperature, which you're going to want to make sure is Kelvin. So if you're given the temperature in Celsius, you're going to have to convert it to Kelvin. Your volume, you're going to want in liters. So if you're given the volume in milliliters, you're going to want to convert it to liters. Pressure is atmosphere. If you're going to given the pressure in millimeters of mercury, convert it to atmospheres first. And amount is moles. So if you're given the amount in mass, convert it to moles before you do anything. Okay, so it's really not that hard to do ideal gas law questions. One thing that might be somewhat difficult is determining which R to use. It's this one, you don't have to determine it if you memorize it, but if you ever get stuck, you have a brain fart, you don't know which R to use, just look at the units, because you always want the units to cancel. So we have liters, atmospheres, moles, K, liters, atmospheres, moles, K, and you see if you put them into here, they will all cancel nicely, so you can determine it that way. Okay, so there's basically two types of questions, two types of ideal gas law questions that you're going to get. You're going to be given ones where you're given three of the variables. So let's say, for example, you're given volume, amount, and temperature, and asked to find the pressure. So that's just pretty much plug and chug, and it's the same for every other variable. You can be asked to find any variable, and they'll give you three other variables, and you just put in the equation, do the math, and out comes your answer. The second type of question you can get is more difficult. It's going to deal with changes. So you have a balloon, it's a given volume, given amount, given pressure. What's the temperature? Okay, so now let's double the pressure or double the amount and see what the temperature is if the volume and pressure don't change. Okay, and by doing that, first you have to find the initial condition and then the condition after and subtract. And I have an example that I made. Ah, fuck. No, I shouldn't have said that word. I'm sorry. Okay, so my question is here, where you have on an alien planet where the atmosphere is completely helium and the pressure is 15.7 atmospheres. So I'm asking how many moles less are in 1 cubic meter when the planet warms from negative 100 degrees Celsius to 50 degrees Celsius. Okay, so what are we going to do here first? We're going to see what we have. And actually, I did this question, and I'm going to hide that. You can't see that yet. And then realized that my mic wasn't plugged in all the way, and I have to redo everything. And I'm not going to rewrite everything because I'm lazy, so I'm just going to drag this slowly out of the way. Okay, so these are variables that we know. So we know PV equals nRT. We know pressure is 15.7 atmospheres. We know temperature is negative 100 degrees Celsius. Excuse me, but we can't use Celsius. We need Kelvin, so we just add 273.15 to it, and out comes our degrees in Kelvin. We know our volume is 1 meter squared, but we can't use meter squares. We have to use liters, and there's 1,000 liters in 1 meter, so we use the 1,000 liters. Doesn't that work out nice? And R is a constant. It's always this. Nothing too special. Okay, so let's drag this down a little bit more. All right. No. Oh boy, I don't know how I'm going to do this. I do so know how. Boom. Alright. Okay. There we go. So, we can rewrite the ideal gas law equation however we want. And in this case, you're trying to find moles, so it's probably convenient to have moles by itself. So, we have moles equals PV over NR, or PV over RT. And then you just sub in the values. So we know pressure is 15.7 atmospheres, and so on and so forth. Do the math, and you find out that there is 1,000 moles initially, which seems fairly reasonable. If you ever doing ideal gas law questions and you get anything like 10 to the power of 8 or 10 to the power of -7, you want to go back and check your math, because yeah, it's not quite normal. Okay, so we know the initial state now. How many moles are in the initial state? But the question is asking how many less moles. So to find out how many less moles, we have to find out how many are present after as well, which is basically the exact same thing, except now you have a different value for a different temperature value. So now for temperature, instead of your 173.15, it warms up 150 degrees from -100 to 50 degrees. So you just put that in, and the according value is 592 moles. Okay, so the question asks for the difference. Ugh. So, oh no. Now what do I do? Okay, question's gone. So, now how do we find out the difference? Well, that's easy. You just subtract them. And you'll get that the final value is 512 moles, which doesn't seem that unreasonable. It seems pretty normal to get about that much. Okay, so I think that's about good for this video.